Don't worry. So first of all, it's my great pleasure to thank the organizers for the invitation to join this celebration of the 60th anniversary of the Zira Appreciation University. I was lucky to be welcomed and to be trained in this institute as early as 1981. And I would like to take this opportunity to express my gratitude to my teachers and to the institution. It's thanks to them that I have become the historian of mathematics that I am. I can measure all that was accomplished for the Institute to reach its 60th birthday and its present state. And I wish to congratulate all those who have worked very hard to achieve these results. May the Institute keep on growing and flourishing for the decades to come, and let us hope that in 10 years from now, we'll all be gathered in this room to celebrate. So now I'm going to talk to my talk, and you will see interesting echoes with some of the talks that were given this morning. To address the issue to which our conference is devoted, namely China and the world in global history of science and technology, I have chosen to return to a topic on which I've been pondering for more than 30 years. But I hope to return to it from what you will consider as being a new perspective. Indeed, in the last 30 years, I could not help feeling some fascination for a very specific practice in mathematics. A practice that is in fact documented in China, in India, and in the Arabic world, and this for quite a long time span. This mathematical practice consists in working with computations, or if you prefer, working on computations, in some places also working on diagrams, using an erasable surface, and using this surface in a very specific way. Often, this surface has been taken to be merely a tool. However, I have long been struck by the stability over centuries of the practice. And this, in my view, doesn't fit very well with the idea that this surface would be a mere tool. I've also been struck by the fact that one could establish correlations between concepts that were used and the practice in question with this erasable surface. One could even perceive a whole conceptual history developing in relation to the use of this surface. So this is a case in which it is impossible to separate neatly between the practice on the one hand and the mathematical results on the other, because they are intertwined. This might explain the stability of the practice. Finally, I have also long been struck by the echoes between some Chinese sources, Sanskrit sources, Arabic sources that one could notice in this respect. Mathematical documents in Chinese, Sanskrit, and Arabic documents that the mathematical practices to which they attest brought into play similar types of surfaces, and they testify to the fact that these surfaces were used in quite similar ways. Today, I would like to return to the uses of such surfaces in mathematical practice to offer from this perspective some reflections on our topic of reflection. But to begin with, let me illustrate illustrate the practice in question by reference to a Chinese tradition in which what I call erasable surfaces have been central. And for this I will rely on a tradition in China that is embodied by the mathematical canons and ancient commentaries, canons that were gathered together, selected by Li Chunfang and colleagues of his, presented to the throne in 656, and were immediately thereafter used as textbooks in the school of mathematics. So the order that I have chosen to put on this slide is not an order which is chronological, but it is an order that Alexei Volkov has recently argued was the order of the two curricula, the elementary curriculum and a more advanced curriculum. So one sees that the elementary curriculum began with mathematical canon by Master Sun, and I will turn shortly to the beginning of this canon, and I will also evoke the third canon that was taught, and for which 3 years were required in the mathematical education. There is a very central assumption in what I'm going to present to you, and that is that the fact that these books were used in the same curriculum implies that for the 7th century actors, they represented a homogeneous corpus of texts. And in particular, I assume that what the mathematical canon by Master Sun places at the beginning, which was taught first, is a practice, or represent practices that were used for all the other canons. Indeed, at the beginning of this canon, the text describes elements of mathematical knowledge, namely how one used rods to represent numbers on a surface, and I call this surface erasable because you can move the rods, you can delete the rods, you can change the value, you can use them in a dynamic way. In addition to this, what the mathematical canon by Sun describes is what we call a place value decimal system, namely that when you have 1, 2, 3, the 1 means 100 in relation to the position in which it is placed. Moreover, the canon describes how to compute multiplication and division using this number system. Now, the problem with this is that all texts that we can read from this time period look like this, namely only characters and nothing but characters. The practice with rods on a surface did not leave any trace at the time in the writings, so it must be restored based on the documents and based on several clues. I'm not going to dwell on this issue here, but here is how everybody agrees to restore what mathematical canon by Sun describes. What I would like to point out here is something very specific in this way of calculating on the left-hand side the multiplication and on the right-hand side the division. First of all, I have deleted rods not to confuse the matter, and I'm using so-called Hindu-Arabic digits. So for me, the key phenomenon here is you can see the computation as a movie that unfolds from top to bottom, What is essential in this practice is that if you compare left and right, you will see two movies that are displaying the opposition between multiplication and division. So, through the dynamic of the computation, of the execution of the operation, something is told which has a mathematical meaning. For instance, you can see that on the upper row, multiplication begins by 2 digits, whereas division is empty, and the reverse holds true for multiplication and division. And you can see that in the upper row, digits will disappear progressively until the upper row is empty on the left-hand side, and exactly the reverse process will happen on the right-hand side. The upper row will be filled up, whereas the middle row will be empty. However, in both computations, what happens to numbers placed in the lower row is the same. So there is a way of dynamically writing the relationship between the operations. This will be my first phenomenon. Second phenomenon, you see on this screen that the positions that are used to write down numbers, here I have 1, 3, 1, 1 for 1311, these positions occur in a system of positions. So you do not have only positions to write down numbers, but you have a system of positions, the positions for computation and the position to write down the numbers. Place value notation, 1, 2, 3, using position with a mathematical meaning, occur in a set of positions that are used for mathematical practice. Third phenomenon, in the 9th century or the 10th century, we begin having in the text, I cannot find my mouse here, we begin having in the text new types of inscriptions, namely representations of numbers written with rows. So now we begin having on paper traces of the material practice that had been used but outside the writings. This is the beginning, or at least what we see owing to the sources as the beginning of a major shift in the nature of the mathematical writings in China, major shift that will have writings that will lead to writing of this kind. This is Tintoshaw's mathematical writings in 9 chapters, where you see that within the pages of writing now, you have the representation of what happens on the surface. And here, in fact, you have the display of a division. I'm not going to dwell on it, but what I will ask you to believe is that this division has the same features as the one we have restored from mathematical canon from master studies. So almost 10,000 years of stability in the way of displaying computation. So using the movie of the execution on the surface to inquire into the relationship between operations. We have seen this for the relation of opposition between multiplication and division. In fact, this practice also occurs in the 9 chapters, to which I now turn. And here you have 2 other operations, square root and cube root, that are in the text described. I've placed in blue the terms that are coming from division. They are described as division. I've put in red what differs between division and root extraction, but you can see that in the same way, root extraction, square root and cube root are written down in parallel with each other, so we again meet with the inquiry into the relationship between the operation, and this corresponds to the fact that on the surface you have this square root extraction, which is shaped as a movie, as if it were a kind of division deriving from division. So again, the movie of the execution on the surface tells something about the relationship between the operations. The result of this reflection about the relationship between the operations can be seen from the terminology, where you see that root expression, whether it's b square or cube, is prescribed as a kind of division, true division, qualified in a certain way, and the qualification is parallel whether one deals with square root extraction or cube root extraction. So you have clearly the terminology showing a structure in a set of operation, which is a structure that reflects what we can see on the basis of what happens on the surface of computation. I will simply mention the fact that in the subsequent centuries we will have a reworking of the processes, a reworking of the relationship, but we can perceive a reflection on the relationship between the operations. Now, what is really interesting is that since the 1980s we have found documents, they have found documents in tomes, mathematical documents, that were written on bamboo slips, found in tomes or on the antiquity market. So far, that many manuscripts have been found, and only 2 of them are fully available for research. These manuscripts also refer to the use of rods, also refer to the fact that numbers are placed on a surface, but we have no hint of a place value system, we have no system of position, and we have no hint of an interest in the relationship between the operations. So it is as if the practice on the surface with position, as I have described it in the first part of the talk, emerged at the same time as a theoretical interest in the relationship between operations emerged. And this is probably carried through the canonical corpus. Recently, Julie Well has found a third corpus, I should say, of mathematical documents, which are mathematical computations in 7th century commentaries on classics. Interestingly here, no positions, no place value number system, no tools for computation at all, no positioning at all, no relationship between operations. So we have 3 corpuses of text. We have 3 corpuses of text, and only in one of them can we perceive this practice and this theoretical interest in the relationship between operations. So, to go back to Qinzhou Shao's mathematical writing, I could have described to you, if I had less strict chairman, it's a joke. I could have described to you how this work with positions, with exactly the same practice with positions, is going on in the 13th century. So we have the continuity of the practice and a transformation of mathematical knowledge along the lines of the program of the relationship between the operation. But what I would like to jump to is to other types of documents. Indeed, in the others known Sanskrit mathematical treatise, and treatise is important here, it's chapter 2 in a wider astronomical treatise, we have the description of a place value number system, which is a number system which uses position with a key mathematical value in the wider context of a use of position in mathematical practice on an erasable surface that is not represented in the writing until very late. So we have the same transfer from a material practice to documents, and we have the same correlation between using position to write numbers, using positions to do mathematics. Exactly the same thing for Arabic documents, at least some Arabic documents. I should have mentioned that it's only in one tradition, in Sanskrit, to be distinguished from that to which the Sola Sutra attests. It's in one tradition that we have the use of position. The same thing in the Arabic world. Al-Khwarizmi's work on arithmetic is lost, but we know from the text and from translations, from the translation, the text and translation, that in this work of arithmetic, Al-Khwarizmi was using positions, both for numbers and for computation. Nothing was inserted in the text, but in the 10th century, we have Al-Khwarizmi, a writer who says, enough with the dust, which was the erasable surface on which people had developed this practice with position, and Al-Khwarizmi now, who is making a synthesis of all kinds of mathematical practices, inserts representations of what was on the dust bowl into the surface of the pages. And you can see here a division which has exactly the same layout as the division that we have seen in the James test of the Canon and Tintusha. Again, Kushlan Luba, around 1000, inserts representation of the dust bowl in the writing. You have here a cube root extraction, and what is really important is that you still have this practice of relating operations one with the other through position on the surface. So, a few sentences to conclude. I think that history of mathematics, when it has looked at number systems, has concentrated on place value system, 1, 2, 3, 1 being 100 instead of 1, in relation to where it was placed in the sequence 1, 2, 3. History of mathematics has focused on results, on knowledge, and then has focused on the channels through which these results have circulated. I think I have made clear that in the 3 cases in which we have occurrences of this number system, these positions are embedded in material practices. A material practice that is using positions to work with operation much more widely. And this practice seems to have been shared with Chinese, among Chinese, Sanskrit, and Arabic documents. So perhaps what has circulated was, first and foremost, the material practice, and with the elements of knowledge that were attached to this practice. And given the close ties between the material practice and the knowledge, it can be understood that they circulate together. This circulation has apparently occurred before representations of what happened on the surface was inserted into writings. Before what is the transfer onto paper, the transfer onto pine leaf of something material that was only carried out with tools and outside the text. So perhaps it was precisely as a material practice that this practice circulated, and not on relying completely on the written word. I have emphasized the fact that in China, in the Indian subcontinent, in the Arabic world, there are different mathematical traditions. In China, different traditions. In the Indian subcontinent, different traditions. In the Arabic world, and only some of them are sharing this practice with a surface and position. Why these, and only these, we do not know. But what I would like to emphasize is that often when we deal with intellectual history, we emphasize Chinese sources as belonging to something together, Arabic sources as together. But what we have seen here is that we have Chinese, Sanskrit, and Arabic sources that are much closer from one another than Chinese sources and other Chinese sources. So perhaps this is an invitation to look at relationship between actual practice, actual material practices, and communities that were shaped by these practices, rather than constructing corpuses on the basis of texts that are written in the same language. Thank you very much.